So I'll introduce myself and then I'll go ahead with the material. So for anybody who doesn't know me, my name is Ciro and I am the co-founder and CEO at Bauplan, which is a lakehouse platform. I'm going to show you a little bit that works and what is the value we provide to our customers, especially when we combine us with our good friends at Orchestra. Mm, I think it's orchestra, right? Because like I'm Italian and I'm biased towards like just like saying it as an Italian word. So, but I'm pretty sure like in English it's orchestra. Okay, so without further ado, let me screen and you should be able to see the materials that we have. Let me kill this one. Okay, so what we're going to talk about today is how to build a declarative data platform using Bauplan and Orchestra and by the means of Iceberg. So what we're going to do is going to start from just like talking very briefly about what is Iceberg and why it is important for data engineers today. So I think Iceberg is becoming like increasingly more important in the tool chain of data engineers these days, and it's becoming kind of the foundation of the architectural changes that we see in these years. Especially a lot of folks are moving from a warehouse first design to a lakehouse design, where Iceberg is the kind of like lingua franca that your data are going to speak. And so really the adoption of this like is growing a lot. You can see just like as a number, you think like if you check the number of companies that are reported to be using Iceberg in the Snowflake portfolio, they increased more than tenfold in just less than a year. So it is an important piece of your stack, and it's important that you have options to operationalize Iceberg moving forward. What is Iceberg? Iceberg is an open table format that brings warehouse capabilities to your object storage. What does that mean? Essentially, the point is this. When you do analytics, we're all used to use warehouses as the center of our stack. Data warehouses are vertical applications. They are built to handle analytical workloads. So you typically use a warehouse to do like analytical queries or data transformation from raw to March, and then an analytical query at the end. So the use cases that you power are typically BI reporting and dashboards. And warehouses have many advantages over any alternative. The first thing that is, I think, like very cool about warehouses is that your data can come like in any kind of format. It can be, JSON, CSV files, parquet files, whatever. Once you put that data into the warehouse, now the warehouse kind of like handles the data, and it becomes like easy for people to manage tables, because tables have a lot of very cool abstractions and very cool things you can do with that. You have guarantees, for instance, that will guarantee that you have consistent writes and you don't have like partial updates that corrupt the tables. You will have to deal, you have schema enforcement and schema evolution. So you have like, your tables, your data types, and a way to keep track of all that. Time travel, which is a very useful feature that allows you to track changes of tables across time and potentially move back to a previous state of your data. That is very useful, especially when you're trying to reproduce something, which happens a lot when you debug, or sometimes it happens also because of the nature of what people do. Some of our customers are in regulated industries, and sometimes it happens that a regulator comes in and asks you to reproduce whatever happened like a month ago or a year ago, and that becomes like very hard if you don't have, the right pieces in place. The other thing is very cool about a warehouse is because it's a vertical system. Once the data is inside of that, you can run queries and you can count on the fact that the queries are optimized. So the queries are just like, you can do partitions, you can do filters or predicates push downs. You can count on the fact that your query engine will handle workload gracefully, even if the query is very large. All these are fantastic things about the warehouse. What is not really cool about a warehouse, and it kind of like increasingly becomes a problem given where the kind of like the space is going, is first of all, they're notoriously super expensive. And if you ever use like Snowflake or BigQuery or Databricks, you know that the cost of running SQL in the cloud at scale is kind of like overpriced these days. But also there's a there's a problem with the vendor lock-in. Once you put the data in the warehouse to have all these affordances that we just discussed, now your data is in the warehouse. So for any situation where you want to get the data out of your warehouse, your cost of doing that is very high. An example of that would be like you decided that your warehouse is a bit too expensive, you want to try something different. Getting the data out of your warehouse is a migration effort. It takes a long time, so it's a high cost for you to switch. A use case that we see more and more often, especially in our specific portfolio, and like I don't know, like if you see that very often in the orchestra as well, is that the data that is in the warehouse is increasingly required to be available to other systems, especially AI. And like now but it's buried in the warehouse, so you have to get the data out and move it around and make it available to other systems, which often are also written in a very different way. So warehouses are also very SQL centric, which is great when you want to do like reporting and just aggregations. But if you need something that is more expressive and you want to do especially machine learning and AI, is actually like very useful, and doing Python on warehouses is hard. I think like warehouses all in all are fantastic, but at the same time, we're starting to feel as an industry that building your entire stack around the warehouse is kind of holding us back in an era where the data needs to be a bit more, you know, uh, available to other systems and available especially to AI. So what's the alternative? Well, the alternative would be to put the data somewhere where it's easier for other systems to consume the data, which could be, for instance, like a data lake on object storage. So it's just like data on S3, for instance, an AWS S3, which effectively would resolve the problem of having data buried in the warehouse and locked in. But at the same time, he's historically being like very messy to deal with data lakes because they have pretty sharp edges. And so typically a data lake is the kind of stuff that an enterprise will do. And they have like a data platform team that does that so that they can build, the governance and making sure that the data is fresh and do all the integrations, do the transformations, make sure that the, different teams have access to the data. So there's a lot of things you need to build. And historically on data lakes, they're built, do it yourself style by large teams. So that's where Iceberg comes in. And so the idea of Iceberg would be, well, what if we maintain the flexibility of the data lake? So we keep the data on object storage. So we lower the cost, both in terms of storage and in the ability of choosing different runtimes. So we get that flexibility, but we also bring all the features that we like about the warehouse. So we represent this data, like the data is stored as a bunch of files in an S3 bucket, for instance, but you interact with the data as a logical table that is an Iceberg table. And the logical table will have all the cool things of tables. You have ACID transactions, you have the schema evolution, you have the time travel, you can query efficiently, and that's it. But you no longer have the vendor lock-in, and you now can also bring like multiple languages in your stack because we effectively, completely separated your storage and your runtime. So if you want to bring like Python along the way, you can, like it's easier to do that. So this is what really like why iceberg is getting so much traction. It becomes like very important. Is basically the best of both worlds. Like is the good things of the warehouse and the good things of the data lake, put them together. Now the problem with that is that the tool chain around iceberg in our experience is still pretty hard. So even though this promise sounds great and it sounds very useful for organizations at very different stages, because like to a certain extent, like everybody wants to, spend less money than the warehouse than using the warehouse, like save money and have something that is more future proof and more flexible. Like all this sounds great for companies at all stage, but because the tool chain is kind of like complex, you have to deal with Spark clusters, a lot of JVM based engines, and they're usually kind of like distributed engines. There's a lot of catalogs that you have to set up and like it's synchronized, which is kind of a job in itself. And you have to deal with multiple integrations, which, kind of bring us back to the first point, that is now we need a data platform team again. So we're back to the problem that all this is fantastic, but it's kind of an enterprise only game because who has the resources to invest massively in a data platform team? Most of our customers are, growing companies in the like mid to late stage, but they don't really see building a data platform team and their own data platform as a very distinctive thing for their business. So they much rather focus on other things. So you don't want to do that unless like it's really, really important. So that's really the problem that we set up to solve is we think that iceberg and the lakehouse design is beautiful and very useful for everybody, but if the tool chain remains very complicated, this remains something that is hard for people to benefit from. So Bauplan is a serverless lakehouse platform that makes your lakehouse, in this case, like iceberg lakehouse, very, very simple. The way we do it is we build on top of your S3 bucket, and we essentially abstract away all the infrastructure that you need to manage your lakehouse, which includes the iceberg piece. So you will deal with iceberg tables and you will get all the benefits from the iceberg table, but you will never have to manage the infrastructure that you need to do that. And the runtime, so the portion of the compute that is required for you to manipulate the data. For instance, you want to import some new data, or you want to transform the data with a pipeline, or just you want to query. So all that is abstracted. So basically, you get iceberg tables with no infrastructure management, and incidentally, no vendor lock-in because the data stays in your S3 bucket as the design of the the design of the lakehouse wants. We On top of the iceberg tables, Bauplan will allow you to deal with those tables in a way that is very similar to how you do it with your code. You will be able to create branches of your data like you do with your code with Git. We call that, in fact, Git for data. And that is very important for experimentations. You can experiment in a safe way without touching production, but also to build very robust workflows. For instance, in all those cases where you ingest multiple sources, you want to do a lot of testing, data quality matters. You can create branches, do all your compute, and then you commit and then merge those branches into your production environment. But it's very easy and it's very kind of Git-like. All the operation that you do in this sense, so building, creating new tables, importing new data, running pipelines, running data tests, running queries, all that is done by a runtime. That is also super simple and abstracted away from you. So there's no infrastructure you need to manage. There's no Spark. There's no clusters. Most important, there's no JVM. So it's just a bunch of Python functions and SQL queries that you can run. And there's minimal ramp up for everyone to understand this. To make this a bit more concrete, what we're going to do today is talk a little bit about, kind of like a simplified version of the design pattern that we laid down with one of our customers. It is called Trust and Will. Trust and Will is a Series C startup that provides legal services. So it's mostly like is an application that allows you to get legal documents, important legal documents like trusts and wills without having to necessarily a lawyer, which has all my sympathy. And so they process a lot of data, and they process also sensitive data because it's regulated legal services. So they needed a data infrastructure that was up to the task. What they were trying to do is migrate from the previous stack, which was just like Snowflake and DBT and on AWS, and then more generally on AWS. What we're trying to do is kind of like leverage this lakehouse design, so lower the warehouse cost, get reproducible and testable data transformation, especially so because it's a regulated industry and it matters a lot to them. And incidentally, kind of like creating now the foundation for them to be more multilingual and have like more Python first data workloads for AI. So to do that, what happened is that they used Bauplan as the lakehouse platform to move a lot of the computation that originally used to happen in Snowflake out of Snowflake so that they can still use Snowflake for the last mile queries, but save a lot of money in moving a lot of the transform computation outside of that. And doing that using the Git for data abstraction is a way for them to ingest the data, create a branch, run a bunch of tests and transformations to make sure that the data that is imported is the right quality, is standardized, is usable for the downstream applications. And if those tests pass, that data now gets published to the downstream applications. If it doesn't, it gets quarantined and they can go and debug or roll back using the Git for data abstractions. And everything is abstracted for them, so it's kind of like very easy for their team to do that. This entire workflow, end to end, is orchestrated by Orchestra. It handles the entire orchestration declaratively. What Orchestra does in this context is Orchestra is an orchestrator that is very based on this concept that you can centralize in single config files your orchestration workflows, and then you deal with them in a very ergonomic and nice UI. And you get out of that like monitoring and lineage out of the box, which is super important because when you want to have the orchestration workflow in place, you like one of the main reasons why you choose an orchestrator over another is how easy it is for me to have a single pane of glass where I can understand exactly what is happening, not only in terms of the execution layer, but also like what the single task are actually doing when they process data. The alternative to something like Orchestra can be kind of daunting. Like often is a bunch of complex frameworks that lock you in. They're not super easy to set up, and frankly, like the monitoring doesn't come out of the box, which is kind of annoying because then you have like now you need to layer several tools just to do that. While with Orchestra, you do this like very simply. You have like a single config file, which is a YAML file. There's minimal ramp up for you to learn that, and everything is managed by in a UI potentially. So also in my experience, like less technical people in the team will be able to participate in this effort and understand where the pipelines are going, which is like very useful when you run like a larger organization.
Mate, you've been paying attention.
I was paying attention. Yes, I used the product, man. Yeah.
No, it's awesome. Yeah. I mean, I think like just an interesting observation from my side. Like what drew us to Bauplan was definitely the declarative approach.
Yeah.
Right. So it's like super cool that you can just like declare your assets in Python. Like it's almost like DBT. Right. But like instead of having to go to a warehouse in the middle, like you're actually just doing stuff on Iceberg, which is supposedly really hard because there are like 15 catalogs you need to work out how to use. But like Ciro alluded to, you can build Orchestra pipelines in UI, but under the hood, it's just a config file, it's just code, and it's also declarative. So, I think we kind of thought it'd be cool if you just like took this declarative config file that could orchestrate anything, but then for the transformations where you can, potentially be orchestrating like, thousands of pipelines, like have that own transformation-centric framework as well. That's also declarative because it just makes it so much easier to use, I guess.
Right. And I think like one important piece that we see more often these days, like it's kind of a separate conversation, but we see this like more and more, and like we're pretty excited about it. It's also the fact that the people are using more and more, of course, like AI assistants to do a lot of their jobs. And like now a lot of that happens like around like code generation. To be fair, anything that is like anything that has a very clean UI for a human to work with, but has a very simple at the same time code first alternative to configure everything has it as an intrinsic advantage when you want to use like an AI system to help you out. Just because like an LLM is basically text in, text out. So if you express everything in a config file or everything as code, in the case of Bauplan, we will see that like both the transformation logic and the infrastructure are just like Python or SQL in the case of like certain portion of your transformation, but mostly Python. Like that is it's very easy then to kind of just like get Claude code and say just like, look, there's a bunch of stuff that I need to do here. Can you figure it out? Like everything is one repo. Just like read that, get an MCP server, and do your job. As opposed to more traditional players that maybe have built like some of their moats around complex and very feature-rich UIs and only UIs. Having said that, I think we can jump into a demo and just like show you how this works. The demo will basically just do this. Well, I mean, with the exception of Snowflake, because we won't have time to just like do also the querying in Snowflake. But it's a very easy thing to do. Like once you write an iceberg table, then Snowflake reads iceberg as a natively, so it's very easy then to use iceberg to use like different tools to read and consume and consume the data. But what we're going to do is basically just like take some data that we have in an S3 bucket and import the data into our lakehouse. And while doing that, we're going to use this. We're going to show you how this Git for data abstraction works. Once we have our golden table published, we can run a query on them, and we'll pass it over to the orchestration layer and see how Orchestra will give observability features on top of this. So very practically, this is what it looks like. So Bauplan is very kind of like code centric in the way you work. So first thing we're going to do is, first of all, I think we're going to pip install Bauplan. So keep in mind that I took the time to, of course, like to have an API key and have like my token set up. If you need to do that, you just, go here, you just like go sign up and you can get like your API keys pretty easily. Here you can get like your API keys. But anyway, like outside of this, once you have like your API key to connect to Bauplan, you can just like pip install that and literally import it in your script. The first thing we're going to do now is create a new iceberg table and just import some data in it. You can see that this is just like a very simple Python function. So this is what we're going to use as a client. And then a bunch like our methods that are built in, they're like create table, for instance, where you say it's like, oh, this table name, this is the S3 bucket. We're going to build this table in, and this is the branch name because, as I mentioned, Bauplan works with this branch abstraction. And then we're going to import data in it, and that's it. And then that's really how you get the entire thing done. So the first thing we're going to do is we're going to create this branch, so we make sure that what we do makes sense. So this branch, as I said, is a Bauplan branch, so it's not a Git branch. So this branch is a branch that is a zero copy of your data. It feels very Git-like because, like, as you can see, it's a Bauplan checkout branch and so on. But what we just created now is an isolated environment for your data. So you have all the tables that you have in main, but whatever we write now, like for instance, if we now, let's run this script right here and just do boink this. If we run the script now, the system is going to create a table and import some new data. We will see that when the data is imported in this branch and not in the main branch. But we will be able to now, query and deal with this iceberg table like any other table that we have in the lakehouse. And it takes just like a couple of lines of code, really. So yeah, okay. So this is done. So if I go now in my UI, go into my catalog. As you can see, like here, I can go and see, well, this is my new branch that I just created. And the table is called taxi metadata. So it's this one. There you go. This is really like, this is my schema. This is the data preview of the data I just imported. In fact, like if I really wanted to just like, run, let's say that we want to run a query on top of this table that we just created. We just like do this. We're done. That's what it is. But we just like imported like our in the iceberg table. There's nothing to manage. You actually never like even heard of like the word iceberg in the code. Like it's just like goes completely abstracted. Now, as you can see, if I go back into my main branch and I run the same query, this is not going to work because this table doesn't exist in my main branch just yet. It just exists in the branch that I created. We're going to merge it back. So once I have my new table, what I typically would do as a data engineer is run a pipeline that takes a table and does something with it. So this is what a pipeline looks like. It's just a bunch of Python functions. Once again, all this can be done with SQL. So if you're interested, there's tutorials on the documentations, and it's very kind of like DBT-like. But we're going to go through the Python workflow here. So the important things here are just like a couple of decorators, and one of them will declare the entire infrastructure that is needed for this function to run in the cloud, in the infrastructure that is managed by. In this case, for instance, we say, oh, for this function, we're going to use polars to manipulate the data. This can be pandas, this can be duckdb, this can be pytorch, it can be any Python package you want to install to run this function. The function, going back to the declarative point, now takes tables as inputs, and they are completely defined in code in a declarative manner. Like you don't even know that this is an iceberg table. Technically, you can do like your columns and your filter pushdowns. You see, this is the table that we just imported and created. These are the columns that we're going to import. And so you just like run. It's like running a query against your lakehouse directly, and then from here on, we do just like some manipulation, and then this function here, this called my parent, goes as an input in the next one that is called my child, and is the second node of the pipeline. That's really all there is to it. If you want to run now this pipeline against the executor, we're going to just like do, and the system is going to read this file here, this file is here, and create this DAG, so like to understand the dependencies, bring them back in real time. So all these are like, for instance, are just like print statements that you just have in your code, and write these new two tables in the branch where we are running this. If you want to, this is a pipeline that processes taxi, the New York taxi data set, 1 month of data. You want to do more, but it's like we're gonna add 2 months and do it like bigger. Just change a filter, run it again. This time is gonna take a bit longer, not that much. So this like last time we, okay, so we ran like 20 million rows with 59 million rows. We want to change a version or package because I don't know, polars, we like to have a different version of polars, or we want to have like a different Python interpreter. We change it directly in the code, we run again. This is completely stateless in that sense, but it handles the entire infrastructure. So you never see a container, you never see a cluster, you never see a JVM, you never see an iceberg table or an iceberg catalog. Everything is declaratively defined in your. In real life, what you will then do instead of running things through the CLI, probably script the whole process. The process that I was mentioning before in the slides is kind of like all here. If you have a simple way of doing this, is this one. You know, you're going to use the same concept as before. You're going to use like a client, a Python client, you know, like create a branch, and then you're going to import the iceberg table, or create a table and import the data inside of that branch. Then you're going to run the pipeline, and then you're going to merge and clean it up. That's really all there is to it. So the entire flow of copying your data, creating a sandbox, an entire pipeline, write a number of iceberg tables, at the end of the day is just this. We run this now all along, like all the way. It will basically rerun this entire thing and merge it into the so this is going to take like a branch. Yes. And it's going to merge it into main. So what we did before, it was like querying the data into the branch and not finding the thing into main. That's going to be resolved now. Like this pipeline that we're doing also calls a function that is merge and clean up. If everything goes well, and because it's Python now, you can have all the imperative logic that you want in your code while you define your assets in your pipeline, in your infrastructure declaratively. You have like the possibility now to say like, well, if it doesn't run correctly, or if it comes back with an error code, like you do this, you do that. And that's where you really integrate then with the orchestrator that handles all the, the retry logic and the observability piece, the system at large. This is completed. We go back to our UI. I now go in main. This query here should work because I merged a new table. And in fact, it does. Go here now and I do go. Here's our new table, and we just created. You script this, you put it on a schedule with Orchestra, and you got your entire lakehouse. Infrastructure, nothing to manage, just a bunch of Python files. Everybody can figure this out. It doesn't really require like a firm team or a PhD. That's all I got.
That's so cool. Awesome. I'm just gonna hop in very quickly around the orchestration side of things. I'm not gonna take long because part of the value proposition is that this is all super easy. So this is just a repo. You can see that I've also got some Bauplan code here. So similar stuff to what Ciro was showing before. When it comes to all of your orchestration, like I think we had a question in the chat about Airflow, right? Like, what do you have to do with Airflow? Well, you have to learn the framework, you have to write all of the Python code, and then you also have to deploy quite a lot of infrastructure. So think of Airflow has like a scheduler, database, whatever. But you know, like it's a lot of stuff. With Orchestra, it's just a config file. So this is an example of quite a complicated pipeline, but with Orchestra, you'll probably never have to have one, which is that complicated. If we take a look at the Bauplan job, this is all the code you need to orchestrate all of your iceberg jobs in Bauplan. That's it. And it's pretty cool because obviously when you get AI to like write these config files, like I wouldn't recommend just like writing them freestyle. It'd be kind of painful. But yeah, I think Ciro already has a pretty cool MCP, but that's sort of on our roadmap too. But you can imagine, right? Like when you've got both MCPs in your code editor, like this is going to be so fast. But you know, for now we have basic CLIs that can do things like validate and also import. But like a big thing is fundamentally how easy it is to build. So while everything in Orchestra is like code, we also give you an easy way to build pipelines if you're maybe slightly less technical. And it's super quick. So this is like a really quite unnecessarily complicated pipeline. But you know, let's say you had like, I don't know, like a data prop job where you are landing some data in Parquet. Maybe you have your Python WAP here. So this is the write, audit, publish thing that Ciro was talking us through, where we're turning Parquet files into iceberg files. Orchestra can run that for you, and it's just part of the declarative framework. And then when it comes to do Bauplan run, which is where you're, you know, basically just running through all of these models that you've declaratively defined. So very similar to like a DBT run, right? You don't say like run model A, then run model B, then run model C, right? You just declaratively define everything and then say run. Like same thing with Orchestra. We basically have a Bauplan integration that allows you to easily connect to the sort of like Bauplan cloud, and then we orchestrate all of those jobs. And again, you know, we can do things like add in retries. Orchestra will intelligently like retry models in Bauplan from the point of failure, so you don't have to rerun everything, which is pretty cool. You know, we can put in like things like the timeout, the delay between retries. This is sort of like that layer that gives you the confidence that your pipelines are going to succeed. And it's fully managed. But yeah, that's basically it. Like, you know, this is not many lines of code. You can see adding that config is just a few. And you know, I think a huge benefit people talk about is that lineage. So with that Bauplan job, you can see that it's just triggering a Bauplan run. But what Orchestra does is get all of the underlying lineage, so you can see exactly what models depend on what. And then obviously you have all of your alerting, all of your metadata, everything is sort of all stored automatically. So yeah, I think this is really it, right? So Ciro, I don't know if there's anything else you wanted to run through.
No, I just wanted to add like the like I think like the configuration driven aspect of Orchestra like plays very well with our design pattern, like mostly because like what you want to do, you know, like your job as a data engineer, in my experience, tends to be like building a bunch of new stuff and integrations. You don't want to spend a lot of time there, so you want to have like very simple systems. And half of your job will actually be dealing with things that misbehave, which is a big part of what you do. It's kind of like debugging and trying to understand what happened. So if a system is really built in this kind of like very transparent way where everything can be defined as code and propagated across different systems, it's very simple then for you to, for instance, like you showed that you have a job ID that ran like a Bauplan job. Like from that job ID, you will be able to retrieve the iceberg tables that were built and the version of the iceberg table that were built. So when you want to debug, you will be debugging your orchestration layer, you will debugging your transformation code, but you will also be debugging your data. And if these three things like live in completely separated systems, you're debugging three systems. Right?
Yeah,
So like in this way, it's just like you can debug like everything in just orchestra, and that's it. Which the thing is like really teams design is what really compelling at Trust and Will in that sense. Like the lineage goes up.
There's also like an audit component, right? So you know what happens when it's the end of the year, but then the CTO suddenly knocks on your door and says, "Hey, like we need to get all the audit logs for our regulator. We're not sure all the data we've been sharing with them is actually correct."
Yes.
Like, what do you do then, right? It's like, do you already have all of this metadata stored somewhere?
Or backfills. Like another thing like that is backfills, right? Like it's like you skip a beat and then you want to kind of like backfill your data. Like that is usually kind of like a fairly complicated thing to do. But if you have a system that has built-in versioning, like that, it doesn't have to be that hard. But yeah,
you can just reparameterize the pipeline.
Basically.
But yeah, I know this is a relatively long webinar, but I reckon we probably have about a few minutes for questions.
Yeah.
Everybody has some.
Do we have?
Someone's got to drop something in the chat.
Away from air. I mean, in our case, like not like it depends on what you like. If you want to use Orchestra, I think yes. But if you want to use like Bauplan, not necessarily. If you have like a lot of stuff, it's fine.
Do you mean about Priyanka's question about how do you convince folks to move away from Airflow?
Yeah, exactly. Like I was saying, like it depends on who is directed to. Like, so in your case, I think like you will have to make that argument, and you like, but in our case, like we don't really have to. Your orchestration layer hopefully is kind of like a separated layer.
Yeah.
To be fair, like with Airflow, it might not be often because it's less declarative. Like people cram a lot of business logic in it.
Yeah. I mean, I think the last point we made, I think, is quite key, right? Like, so something Orchestra does is automatically fetches all of the metadata for all of your operations and like can land it in your environment. So if you ever need to have an audit trail of exactly everything that's happened, we have it. And because the Bauplan sort of API and data spec is so good, like every single operation has the sort of like branch hash, the version history. So it's really detailed, it's really good. But the other way to think about it is just, you know, is it like a sort of like a hands-on or like a hands-off implementation? Like my thesis is that Iceberg has a huge amount of benefit, but today, like a lot of the teams that are implementing it have to put in a huge amount of like people resource to get the benefit. Like the cool thing about a Bauplan is it's sort of like the managed version of that, but like to the max, right? It's like all you have to do is write Python and you get all the benefit. With orchestration, it's the same thing. Like as long as you can write a config file, you get a ton of infrastructure and security around the orchestration. Compared to what with Airflow, I'd characterize it as more of like a DIY implementation. So it depends. Ciro, do you want to maybe take Ashwith's question?
Yeah. So when I say vendor agnostic, what I mean is that the data will stay in your I'm talking about iceberg in this case. So the data will stay in your S3 bucket. You will have a system that is probably a vendor like Bauplan for you to manage and write those tables. But if you were to rip out that system, those tables will remain in your bucket. Not only the files, but also the metadata that will comprise your iceberg table. So you can point those tables to another engine. You usually have to register those tables into the catalog of the new engine, but you effectively don't have to move data around. So you can swap your vendors fairly easily there. And as far as Ben's question goes, like what plans do you have for AI? So there's a lot going on at Bauplan with AI because the nature of the platform is really AI friendly for people who use a lot of Claude code. Like most of our users use AI agents to build pipelines or build their data quality tests and so on. One thing that is very important is this. One is the fact that everything is code and that's simple. But the other is this: if you want to use an AI agent or Claude or something to write a new pipeline and run it, you're using an AI system to change some data in your lake, which obviously can be dangerous because like the AI system can do silly things, right? The Git for data abstraction is very powerful for that. You can isolate your data, create a branch. Now you can use an agent to help you out building what you need to build. And you don't really have to worry too much about the agent running a query that is, that is dumb, really, or that changes some schema or some tables that your systems will depend on. It's isolated, so it's very secure and very air-gapped. It's perfect for agents.
Love it. Cool. Ciro, what about okay, we got another one. How do you handle data conflicts during merge?
That's a very good question.
Is the answer trunk-based development?
No, I like because it's a sensitive matter, the system right now is very conservative. So you branch from your pipeline. If in the meantime the branch from which you branched changed, you will not be allowed to merge as is. You will be required to rebranch and rerun. But for now, like we handled that like very, very conservatively.
Okay, so riddle me this then. Like, if I need to do like a Git rebase, like, do you guys also handle the sort of like rebasing of the data?
That's my point. Like that is on our roadmap.
I hate doing Git rebasing. I'm very stupid.
Nobody likes that.
I don't even know how to do it.
Yeah, nobody likes that. I understand, but like no, I think like a proper rebase in the sense of Git right now is not available, but is on our roadmap. What is available is like it's kind of like conservative way of doing things that at the least will prevent you from overriding your main branch with a branch that got old in the meantime. In the meantime, so it's a little bit more like simpler than the full Git system right now, but it's coming.
I mean, I guess part of the joy of Bauplan, right, is that it's just so fast. Like you can just make another branch and just call it there, right? Like it's not like you're going to be sat for like 10 minutes creating a new branch just because
No, but the branch is a zero copy operation, so instantaneous. The merge is an atomic operation, instantaneous as well. And the runtime is optimized to run stuff. So I think, especially if you're a Python person and you're used to kind of like running Python, in the cloud in a more kind of like naive way, there's a lot of data moving around and a lot of just like container building that will make like your execution very slow. All that is extremely fast in our platform because it's built specifically for this use case.
It is really fast. I was just I was doing a demo earlier for DBT and Databricks today because in Orchestra you can run DBT, and like I'm still waiting like a couple of minutes for my cluster to start. And like it's annoying.
That's the beauty of serverless, right? Like you just like get it in.
Yeah. And Orchestra is also fully serverless. So
Orchestra is very fast.
Yeah.
I can attest that it's very quick to build a task in Orchestra that I did today for the demo.
Indeed. Cool.
So we did have justify workload back to Spark. Thank you. Like this very good question. So Bauplan right now is single node. So the short answer is yes. Up like over a terabyte. If your workload like crunches more than a terabyte, you will probably need to go distributed. And then it's up to you to choose like whether you choose Spark or Ray or Dask. I think like I'm not sure like what is going to happen to Dask, but that you need like a distributed system for something like that. For anything that is below a terabyte, we're faster, simpler, better, cheaper. It is. In my experience, most workloads stay below the threshold, but it kind of depends on what you do.
Yeah, it'd be interesting because I remember we had a talk from Booking.com in Snowflake HQ in London the other day, and I think they did one of the biggest iceberg migrations ever. And they said they like had their own bare metal servers to like move data across with iceberg, and they were all Spark.
I think Booking was migrating to the cloud. Like they might actually manage that thing like from the ground up.
Yeah, they do. It's a huge deal.
So for the pricing model, so we price per capacity actually. So all the runs that you run inside of that capacity are free to a certain extent. Like you don't pay for how many runs you run. You pay for like how large is your largest workflow. We tend to be like we can get like to sometimes like 10x cheaper than stuff like Databricks. But basically what you will be able to do is run as many pipelines and as many interactive queries against a machine that is provisioned for you. Bauplan is also single tenant. So remember, like the data is processed in an environment that is yours and only yours. So you don't have to worry about like data being sent over the internet or in a multi-tenant environment. We see the upper end of data volume of Bauplan would be a good fit. The upper end of data volume for Bauplan would be a good fit for. I think like is the biggest machine you can get from AWS right now, which is approximately a terabyte.
That was good. You always need a few more questions at the beginning to get everyone coming, and they're still coming. Thank you, Andrea.
And you perform iceberg table operations like compaction of time travel directly with Bauplan. You don't have to. We do it for you. So time travel. So a couple of things like compaction is a separate thing. Is in like that is managed. Time travel is built in the platform. So if you want to time travel using Bauplan, what you will typically do is you will have a hash of a table or a number of tables that is like in the commit history of our Git for data will point you to that table point in time. And you're going to pass that hash as a parameter to the methods that you're using. Like for instance, if you do a query, you will do a query. and then you pass the parameters at ref. That ref is an hash that time travels back to a certain point of your commit history.
Awesome. Well, thank you everybody for joining. This was yeah, fantastic turnout. So hopefully it was enjoyable.
Thank you very much, Ryan. I can answer that question asynchronously. I'll follow up on LinkedIn or something.
Awesome. Yeah. We'll pick out some contact details, pick out some resources on how to get started. But yeah, like everybody, you all know where to find us. So yeah, just I guess happy holidays. Hope everybody has a nice Christmas for those who celebrate. And yeah, like happy.
Yeah, see, I'm in my childhood bedroom. Like I'm home for the holidays. You can see that. This is like this is not what my office looks like normally.
Good stuff.
A good one. Thank you very much. Happy holidays.
Everybody. Ciao. Grazie mille.
Bye.